Hello, hello everybody, and welcome to our webinar today, Enterprise Class GenAI with RAG. Very excited to be here. We have a packed house, but just before we get started, a couple of quick housekeeping items. The webinar is meant to be interactive, and there's a few ways you can interact with us during this webinar. In the bottom right hand of your screen, you will see some buttons for chat, for questions, and polls. We'll be taking Q&A throughout. You can submit a question throughout the presentation at any time, and we'll answer all your questions at the end of the webinar. You will also see some polls show up from time to time, and please take a minute to answer the questions as they show up on your screen. And then finally, you can also chat with us using the chat button. One more thing, the webinar is being recorded, and you will get a link to the recording in your email. With that, let's get started, and let me turn it over to our host today, Sushant Rao. Sushant, all yours.
Great, thank you so much, Ramaz. So hi everyone, my name is Sushant. I run marketing at Baffle, and I'm pleased to be joined today by two great speakers. Let's have them introduce themselves. Parth, would you mind introducing yourself?
Sure, thanks, Sushant. Hey everyone, my name is Parth. I'm a senior startup solutions architect here at AWS. I've been with the company for about 7 years now. I started off in the databases and data migration space and moved to startups about 3 years ago. I typically work with ISV startup customers in the cybersecurity domain. Thank you to Baffle for having me on here, and excited to be here.
Awesome, and thank you for joining us. And our second speaker is Minhank. Minhank, would you mind introducing yourself?
Sure. My name is Minhank Ko. I currently head up the product team here at Baffle. I've been in the database and just data security industry pretty much my entire career, over a couple of decades now, so who's counting? But in any case, happy to be here. Looking forward to sharing what little I know with everyone.
Well, you know more than most. So thank you for joining us. And so, folks, today we'd like to start off with a poll question. So you should see a pop up on your screen, and the question is your organization using RAG with sensitive data from databases today? And choose the answer that best describes your situation. So your choices are: we're using RAG but not with sensitive data, we're using RAG with sensitive data but the data is not coming from databases, or we are using RAG with sensitive data from our databases, or we are not using RAG. So go ahead and submit your vote. All right, let's see, where's to click the polls to see what the responses are. So it looks like we have a wide variety. I would say more people are not using RAG than are using it, but there are people using RAG with sensitive data, and they're using it from databases. All right, so let's skip the next slide, which is just the poll. And now let me turn it over to Parth to talk about Amazon Bedrock.
Awesome, thanks, Sushant. So to begin our webinar today, we're briefly going to talk about Amazon Bedrock and its capabilities, and how AWS enables you to have an end-to-end RAG workflow. So Amazon Bedrock is a fully managed service that makes high-performing foundational models from leading AI startups and Amazon itself available for your use through a unified API. You can choose from a variety of foundation models to find the best suited for your use case. And using Bedrock, you can easily experiment with and evaluate these foundation models for your use case, privately customize them with your data using techniques such as fine-tuning and retrieval augmented generation, build agents that can execute tasks, and all of this via a serverless experience. So before we dive into it, I also have a quick poll. I just wanted to get a sense from the audience in terms of which LLM have you interacted with through Amazon Bedrock. You should see the poll come in. Okay, I see a mix of answers here. Some of you have used Mistral, Llama 3, Claude 3 as well, and some of you are fairly new to it. So this is an awesome opportunity, right? Okay. Cool. So what does Bedrock offer, and how does it simplify things with generative AI, right? So customers had told us that there were a few big things that stand in the way of using foundational models more broadly. So firstly, that there is no single model optimized for every task, and models are continuously going to be improved with newer advances in technology for the foreseeable future. So, for any particular use case, customers often need to put together several models that work with each other or upgrade the same model to the newer version. This can take time and resources. Therefore, Bedrock offers you a variety of choice in terms of the large language models that you can use. Secondly, customers want it to be easy to take the base foundational model and build differentiated apps using their own private data. And since the data customers want to use for customization has incredible value, they need to stay completely protected, secure, and private during that process. Third, customers want integration into applications to be seamless without having to manage huge clusters of infrastructure or incur large costs. And the fourth is Bedrock does provide and simplify security and governance controls. And we also do not use your content to improve the base model, and it is not shared with the model provider as well. So Bedrock today provides access to a wide range of foundational models from leaders like AI21 Labs, Anthropic, Cohere, Meta, and Stability AI, as well as our own Amazon title models. The most important feature of Bedrock is how easy it makes it to experiment with, select, and combine the wide range of these foundational models. It is still early days, and we're all just getting started. Customers are moving fast, and at the same time, generative AI is evolving so quickly with new options and innovations happening practically every day. This need to be able to experiment, deploy, and iterate, and as well as pivot quickly is what Bedrock adheres to. This is why we've made building with a range of foundational models as easy as just running an API call. So let's get to the main topic for today, which is generative AI with RAG. So what is retrieval augmented generation? This is a process of optimizing the output of a large language model so it references an authoritative knowledge base outside of its training data before generating a response. Large language models are trained on vast volumes of data and use billions of parameters to generate original output for tasks like answering questions, translating languages, and completing sentences. RAG extends the already powerful capabilities of LLMs to specific domains or an organization's internal knowledge base, all without the need to retrain the model. It is a cost-effective approach to improving LLM outputs, so it remains relevant, accurate, and useful in various contexts. So the goal is to create an application that can answer user questions in various contexts by cross-referencing this knowledge that you have. It could be company data, it could be documentation, it could be source guides, right? The nature of LLM technology introduces some unpredictability, which is why retrieval augmented generation plays a big role in this. Let's look at a RAG workflow in action. So the user makes a query to the generative AI application, expecting a response back that is accurate, creative, and is backed by private data. Next, behind the scenes, the generative AI application takes the following actions. It will use the prompt that is sent to the application and pass it on to an orchestrator. In our use case, it's a LangChain orchestrator. LangChain is an open source framework for development of applications using large language models. It is available both in Python and JavaScript. and provides tools and APIs that simplify the process of building LLM-driven applications. The LangChain orchestrator then generates and passes the prompt onto an embedding model. An embedding model is used to convert the prompt that you send to the application into vectors. Bedrock currently supports a couple of embedding models, which is Cohere and Amazon's own Titan embedding model that help with generating these embeddings. And the embedded query is then passed back to the LangChain orchestrator. Using these vectors, we query our data store. Our data store contains our own private data. This data store is specifically a vector database and has our data stored in representation form as vectors. We perform similarity search based on the query embedding and receive document context back to the orchestrator. The orchestrator then augments our prompt with the context received back and then prompts the LLM with it. So the initial query asked by the user and the document context from our data store are both passed along to the large language model. The LLM then generates a response. Finally, the orchestrator passes the generated response from the LLM back to our application, which is returned to our user. So at AWS, we have added a wide variety of data sources that enable customers to build semantic vector search. The services listed here, such as OpenSearch, Amazon Aurora, DocumentDB, DynamoDB, MemoryDB, as well as Amazon Neptune, all of these have vector capabilities. So this gives customers the flexibility to work with data stores of their choice and build generative AI applications. We'll be focusing on PG Vector today, so narrowing down our focus a little bit more. Now let's look at why PG Vector, Amazon Aurora, and what is the importance of storing vectors and data together. There are a few advantages of doing this. So the first one is using familiar tools that meet your requirement. Let's say you're using RDS or OpenSearch. They have vector search as a feature. It makes it easy for developers to use tooling that they are working on with a daily basis. The tools and databases used under an open source license also avoids any contract management. This provides a faster experience to the users in terms of experimenting, deploying, and rolling out generative AI applications. And when your vector stores and business data are stored in the same place, your applications will run faster, and there is no need for any data sync or data movement to worry about. Now, answering the question as to why PostgreSQL for vector searches. Postgres has existing client libraries to work with without any modification. It is convenient to co-locate the app and data in the same database. This removes the management overhead from an infrastructure perspective. And Postgres can also act as a persistent transactional store while working with other vector search systems. So PG Vector is a PostgreSQL extension for vector similarity search. It can be used for storing the embedding that you generate for your data. It provides indexing features which allow us to enhance search capabilities and minimize the time required to identify the nearest neighbor to any given vector. It gives us the option on the search algorithm to be used between k nearest neighbor and approximate nearest neighbor. You can also enable metadata tagging, which you can co-locate with the embeddings. So these also can help in faster search and retrieval. And PG Vector also has deeper tuning controls in terms of what type of indexes that you want to use. In particular, it offers IVF flat and HNSW. PG Vector is available on Amazon RDS and Amazon Aurora. So the key capabilities that these products offer are as follows, right? Number one is scale. It allows us to store billions of vector embeddings together. Aurora and Amazon RDS both have native indexing capability that open source self-managed Postgres offers. Amazon Aurora has a feature called optimized reads, which can increase your search time up to 9x in certain workloads, specifically the ones which are memory intensive. And it also has support for integration with frameworks that are used widely, such as LangChain. The top use cases that we have seen are with using PG Vector for RAG is product recommendations, sentiment analysis, chatbots, Q&A, fraud detection, and many more. However, when it comes to actually implementing retrieval augmented generation, there are a few challenges. RAG architectures involve multiple components, including a database, retrieval mechanism, the prompt itself, the generative model, and managing these moving parts can introduce some sort of complexity. The integration of retrieval and generation also requires additional engineering effort and computational resources. Though we do have open source libraries such as LangChain, which provide wrappers that takes away some of this heavy lifting, changes to the libraries can introduce errors and add additional overhead of versioning. Even with these open source libraries, you still have to write a lot of code, determine the appropriate chunk size, generate the embedding, augment your prompt, and so on, which may take weeks of effort depending on the volume of data you're working with. To solve this, we have knowledge bases for Bedrock. This provides you the capability of amassing data sources into a repository of information. With knowledge bases, you can easily build an application that takes advantage of retrieval augmented generation. Knowledge bases provide fully managed support for an end-to-end RAG workflow. We will dive into the managed aspect of this feature in a couple of slides. You can easily select and connect to the foundational model and agents to your data sources. And it provides a very nifty API that helps you easily retrieve data and augment the prompt itself. Another feature that it does have is providing source attribution, which makes sure that you are referencing legitimate data that you own, and the foundational model is using that to provide a response to your customer. Looking at the RAG workflow from a knowledge base perspective, right? So a user query or a prompt is submitted to your application or Amazon Bedrock itself. A managed RAG workflow is executed where the application queries our vector data store, augments the prompt, and sends it for further processing. You can then use the model of your choice and retrieve a response. All this while securely connecting to foundational models and data sources. So taking a deeper look into the ingestion workflow, right? So a typical ingestion workflow with knowledge bases on Bedrock looks as follows. You choose the data that you'd want to store on Amazon S3, then choose a data chunking strategy, choose the embedding model of your choice, whether it's currently we support Amazon Titan and Cohere Embed. Once you choose the embedding model of your choice, you choose the vector store of your choice. Currently, in terms of knowledge bases, we support OpenSearch Serverless, Pinecone, Redis, and Aurora Postgres and PG Vector. Knowledge bases also have support for incremental updates and multiple data file formats. All of these steps are taken by knowledge bases on behalf of you as the customer. So it takes away the undifferentiated heavy lifting of setting up an application which is driven by the RAG approach. So knowledge bases offer two different APIs that are available as of today. The first one is a retrieve API. This API is used to query a knowledge base and only return relevant text and data sources. This is suitable for, let's say, a text generation workflow or even a custom workflow. The user input is converted to an embedding, and the retrieval API is used to retrieve the relevant context from your data source. The second is the retrieve and generate API. So this is the fully managed RAG experience. The user query is passed to the knowledge base. It takes the query, performs a series of steps to complete the retrieval augmented workflow by creating the embedding query, searching similar documents, augmenting the prompt, and generating a response from the LLM. So you can see how easy this makes it to implement and use. For a fully managed RAG experience, I definitely recommend giving knowledge bases and Amazon Bedrock a try. Finally, I'd like to cover one of the most important things to remember is AWS's shared responsibility model. This is applicable even to the generative AI applications that you are building on AWS. Security and compliance is a shared responsibility between AWS and the customer. This shared model can help relieve the operational burden as AWS operates, manages, and controls the components from the host operating system, virtualization layer, down to the physical security of the facilities in which the service operates. So AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud. The infrastructure is composed of the hardware, software, networking, and facilities that run the AWS cloud services. The customer's responsibility is this for security in the cloud. So this means that they are responsible for their data and the security of it. Who has access to that data, what resources and applications using identity and access management, network and firewall configurations, data encryption, authentication, and network traffic protection. This shared responsibility model, as I mentioned earlier, applies to generative AI applications as well that are built on AWS. And from here, I'd like to hand it over to Min Hank from Baffle, who is going to talk more about security for generative AI.
Thank you, Parth. That was a great introduction to all the GenAI services available through AWS. And as Parth mentioned, security is absolutely a concern when it comes to generative AI applications, be it on AWS or even any other infrastructure you might actually use. And maybe just to level set for any of you who perhaps have not really given a thought about security in your infrastructure, one of the reasons why security, or one of the main reasons why security matters for enterprises and companies or just any organization is at its core compliance requirements. Compliance is where these data privacy and data security requirements is where kind of our needs as individuals to make sure that our data doesn't go anywhere willy-nilly is actually kind of addressed by regulatory bodies, be it governments, be it industry groups, to essentially make sure that companies do the right thing. And if I were to really summarize it in sort of a few lines, which I'm trying to do here, it's just saying that companies need to make sure that only the people who need to have access data can access the data, and they've done their due diligence in making sure that the people who shouldn't have access have been prevented from accessing it. The best one way I like to think about it is like banks, right? Where the regulatory bodies for banks essentially want to make sure that the banks are actually protecting your money since they're collecting so much of it. The same way with companies collecting your data, the institutions, the regulatory bodies want to make sure that companies are protecting their data when they have it. Now, how I'm going to approach sort of this discussion about securing the data in Postgres is first I'm going to go a little bit deeper in a review of how one might hypothetically use PostgreSQL in a RAG pipeline. I saw earlier in the poll that many of you are not currently using RAG, but perhaps you're here because you're thinking about it. So hopefully this will be interesting to you. My intent here is as we sort of walk through this, I'm going to sort of discuss the data flows, and later we'll see where the risks come in so that we can kind of better understand the value of securing it. Right out of the gate, I just want to kind of show you where PostgreSQL actually can fit in a RAG pipeline. This is something that you could theoretically replace with other vector databases or other potential source data, but it's actually quite typical for companies that actually are already using Postgres. So imagine you have an application, and I'm going to use an example later, that's a customer service management ticketing app. That application may already be backended by a PostgreSQL database. So you've got a wealth of data there that you've collected through the ages. And now that GenAI comes along, you probably want to figure out a way to tap that to generate insights, to provide your internal team a way of actually getting information quickly. There are all sorts of reasons to try to build a RAG pipeline around it. And of course, as Partha discussed earlier, you kind of have the sort of various stages of the various components that you actually have to pass the data through. And of course, one of them being the actual inference engine built on top of LLM, and of course, a front-end UI. Now, if we to go just a little bit deep, actually, before we go to the next, I just want to take a quick poll here since we're talking about using PostgreSQL. The poll here is whether or not you're currently considering using pgvector as your vector database for your RAG pipeline. Obviously, this is more applicable to those who are already, kind of looking at doing RAG. But if not, just hypothetically speaking, do you think you'll be doing it? Your choices are yes, where you plan on using pgvector, or for GenAI. And then the reason why you might do that is because you're already using Postgres, or you may be using pgvector anyway, even if you don't use Postgres. And of course, the other two options are you're not planning on using pgvector, either because you're using another vector store, or you're just not going to use RAG altogether. So take a minute there to submit your vote. I'd be interested in seeing what everyone says here. All right, so kind of aligned with our earlier poll. Most of the folks here today don't currently have active GenAI RAG pipeline, and actually are probably using a different vector store. So actually, that's good to know, because I'm going to discuss a little bit of how this looks like when you have a PostgreSQL database in conjunction with pgvector, and perhaps why it's somewhat valuable. But by no means is what we discussed today limited to just using pgvector. It is just a common deployment model that we've heard from our customers. Alrighty. Anyway, I'm going to drill down a little deeper into the data flows. Right, I kind of went over the high-level picture, but if you actually start tinkering with RAG, what you're going to find is that the path from your actual source data to the actual vector database is not entirely straightforward. It's not just a copy and generate embeddings, right? Quite often you go through multiple, actually not often, you pretty much have to go through multiple stages where you're actually extracting the information from your source data. You could actually use a table itself, but there are reasons why you actually might want to export your document, do some massaging so that it looks a little bit more natural language and contextual. And I'll have a very brief example in the demo to show you what I did. And of course, after you get the document out, quite often the size is going to be larger context length. So you're going to go through a process, colloquially called chunking, where you're going to split it up into smaller bite-sized pieces where then you generate embeddings on it, and of course index it for fast search. And that's really where the power of using a vector database comes in, where it's obviously already got the embeddings, the vector data types, but also has the various search capabilities, indexing capabilities to actually help you get the right documents out very quickly. So The point I want to emphasize here is that you've got source data that's coming from your application database, which more likely than not is going to have sensitive values. It's going to go through each stages, and each of these stages essentially will be processing potentially sensitive data. And in the end, that sensitive data is going to land in your vector database. And if you're using Postgres, that's going to be your PG vector database. So again, getting even more concrete, and this is one of the reasons why people like using PG vector when they're already using PostgreSQL, is imagine that your hypothetical application, in this case, a customer support ticketing database, has a table there with all the information that you would have. It's kind of really convenient to be able to essentially run a function there, or just take all of that in real time, generate embeddings, and chunk it and generate the embeddings and add the metadata that you need for your RAG, for the rest of your RAG pipeline. It kind of keeps it in sync. You don't have to manage it separately. So that's incredibly valuable. Just do it all in one place. And of course, the thing is that anytime you use, of course, use application data, there's always a risk of sensitive data values. So I just want to highlight a classic example. Even something that you would think as relatively low likelihood of having PII as a customer ticketing table, you're still going to have things like email address, maybe names. If it's a financial related service, you might even get credit card numbers in there. So I'll highlight some examples. The one thing that I've also highlighted, perhaps that might be not as intuitive, is that even the embeddings themselves are actually considered potentially sensitive data. In fact, Gartner recently published a report that explained, this in pretty straightforward language, that it's viewed because the fact that embeddings can be used to derive the original data values, you pretty much have to treat it like sensitive data. The regulations obviously are a little behind in sort of explicit language, but I would fully expect that to be the case, and auditors to basically view that as a potential data type or sensitive data value that you're going to have to protect at some point. So we just talked about what your typical foray into developing a RAG pipeline and using generative AI in a RAG sort of deployment model might look like. Let's sort of examine where the compliance issues come into play. I think I already gave some hints as to what that might be. Right out of the gate, and I have it kind of highlighted in yellow, when you had your original application database with the sensitive data, you actually already were kind of in a gray area as far as that general concept of least privilege access to sensitive data values. Most databases, and definitely with actually all databases pretty much that I can think of, and the PostgreSQL is not an exception, your DBA essentially is a super user that have access to everything that's in there, right? And if you think about the whole concept of need-to-know basis, that doesn't make much sense. The DBA's job is to make sure that the database is running, the schema index, it's optimized, it's efficient, but it really doesn't need to know yours and my credit card number, yours and my social security number. It's kind of a necessary evil that they have access to it, but ideally what companies have to do is actually prevent their administrators from ever being able to have that level of access. Today, what we've seen, obviously, is that quite often they have to accept that risk and explain to the auditors, and that's a less than ideal solution, and it's probably not one that's sustainable in the long term. And of course, as we've discussed, the data moves down the RAG pipeline, and at each stage, essentially is flowing in clear text for all practical purposes, meaning that anybody who can intercept any of these stages can actually see the data values, or at least have control over one of these stages. And one of the key one, where the landing place of all that chunk data and embeddings, is the vector database itself. So the advantage, of course, of consolidating your AppDB and your vector database is that you have a single admin. So I guess you reduce your risk. You just have one person that you really need to watch very closely. But quite often, and I saw earlier in the poll, you might be using a different vector database. So guess what? Whoever it is that's the admin or privileged user for that vector database is now going to be another potential risk and area of where your compliance auditor will take a closer look and make sure you're doing all the right things. And lastly, and it may seem counterintuitive, but your Gen AI user, the person who's actually trying to use this new thing or application or feature that you're doing, is now also a potential risk. Some of you may have already seen articles online about models potentially leaking data. Anything that's trained with can potentially come out despite best efforts to filter it. A similar case applies with RAG, where whatever private documents, whatever documents with sensitive data value, in this case, the data in your application database, can now be accessed through the system by the end user because of the nature of GenAI, which I'm going to discuss next. So to understand why it's an issue, let's kind of take a step back and think about access control in a way that perhaps those of us who work with a database know best, which is you can always grant privileges to specific users, or I'm calling them subjects, to specific resources, which I'm calling objects. And these policies are very clearly delineated, and you can even look up these policies within the catalog or dictionary of that particular database, right? So, for example, I can say Minhank has access to only the subject column or the description column of tickets, and I can actually, if auditor ever needs to check that I'm the one that has that privilege, it could actually dump it out and see it. There's never any doubt that this particular access pattern is enforced by the database, and it's very deterministic and understood. Now, imagine trying to do the same thing with a Gen AI application or in a Gen AI retrieval model. So I'm going to try to limit access to only description. So I shouldn't have access to email address and the like. I still have a concept of a subject or user, that's me. And I kind of have a sense of a permission, which is I want to be able to read it. But now there's really no way to design a policy or sort of a object, to define an object that you could actually assign a policy to. Because the output of generative AI is dynamic, right? You're not going to be able to say, well, Minhank only has access to this generation number one, but not the second time they generate. So that's a challenge with generative AI, is that access control is all screwed up. Whatever original access control policies you have that met all the compliance requirements perfectly, not so much once you pass it through the pipeline. So what do we do about this? Well, I'm kind of set this up to kind of strike home, to get home the point that really there is still a object that you could actually connect the policy to, but it is very granular. What you're going to have to do to really effectively have the same level of compliance, control that you need for compliance, is to actually put the policy specifically on the data value itself. So if compliance requirement says, well, PIIs like email addresses must be controlled, then you're going to have to essentially make sure there's a policy on every single email address value, right? Because your GenAI system can arbitrarily pull that email address value from any document and potentially return it. So that's a challenge of GenAI, but there is a solution, which is if you have a way to control each data value individually, then you've solved the problem. And of course, the good news is that there is a technology that's available to do that, and that's encryption. When you encrypt that individual data value, you basically virtually ensure that you have some control over who actually gets to see it and decrypt it. So we've gone through a journey of understanding where the security problem is for generative AI and RAG, and we realize that we're going to have to protect individual values. It seems like a Herculean effort, but actually it's not. And here's a kind of picture of how you might be able to do it. Let's say that you had a way to encrypt those sensitive data values as early as possible. So going back to my customer service management example, right? I knew at the very beginning of using this application that my customer service, fields have email addresses, have some names, maybe, or have some credit card numbers. I went ahead and just encrypted those as early as possible. What it means is that by the time it gets to the database, even the app database, it's already protected. So I've already essentially protected against the issue we had previously, where the AppDB had too much access. And then as that encrypted data value goes down through the rest of the GenAI pipeline, whether it be flowing to the LLM service, which you may either deploy locally, or if you're using AWS, use their rich capabilities. You'll be sending it off to them. Still be anonymized and not particularly prone to breach or leak. If it gets stored in the vector database, again, it's going to stay anonymized and protected, and the vector DB admin won't be able to have unnecessary access. And lastly, when the PII values, when it comes back to the user, it also will be anonymized. Now, there might be cases where you actually need to have access to it at the end user level. For example, let's say that maybe I don't have the right to have the email address, but maybe someone marketing, because of their business need, have the right to the email address. You could imagine a way where you just simply check before you return it whether or not that particular user has access and decrypt it as needed. So the gist of it is encrypt as early as possible so that you actually gain control at the field level, and of course decrypt at the field level when you're about to present it. That's that's a proposal here. And of course, the good news is that Baffle actually provides a complete solution for how to do this easily with no code changes. Right, we'll encrypt the data for you through a network proxy that essentially requires no code change, and the data will land in the application database in encrypted form, and will actually allow you to drive all of that through policies in a centralized manager that you could then provide to your auditors for compliance reporting, so that you've checked that box for compliance. And of course, upon the presentation of the data back to the end user, that same policy can actually drive whether or not to decrypt it and ensure that only the people who should have access will have access to the data. And that's the key point for compliance, the need to know basis aspect of it. Of course, as you can see, I actually prefer to go sort of into the details a little bit, and apologize if I've been in the weeds. To sort of go further down that train, I'm going to sort of do a demo. And given the time frame, I don't have the opportunity to demo the entire pipeline. So I've kind of scoped it to just the part that perhaps people might be most interested in and have some question. So I've already gone through this process of encrypting as early as possible. So I'll have a Postgres database with just a trivial number, like 5 tickets, and this is a hypothetical application, it's not a real one, where I've encrypted some PII values. And then just like any other pipeline, I would RAG pipeline, I have extracted those and basically generated vector embeddings out of them along with metadata. And then, of course, built a front-end UI that essentially is doing a augmented retrieval to actually present the information back to the user. So with that, let me see if I can share my screen. Share video, share screen. All right, give me a second here. One of the things that tends to happen initially is you're going to get this effect where everything, okay. All right. Hopefully you're able to see my screen here. What I have here is a picture of pgadmin, which is a typical way that administrator might actually access the database. What I want to show you right now is that the database with encrypted data. I have a direct connection to my CSM database. I'm just going to do a quick simple query against it. If you recall, I've already encrypted it as early as possible. So what I should see in this table is ticket ID, email, phone, credit card has been encrypted. Because the way it presents it, it's byte A, so it just has the byte data. But the rest of these are in clear text because I don't deem those as sensitive at the moment. Just to show you what the encrypted values will look like, I'm going to do a select and convert those columns to text. And you'll see that we have our own special prefix, BAFF1E, to describe so that we know it's encrypted data values. So as you can see, we've got a bunch of encrypted data there. And then, of course, what happened is, as I described earlier in that pipeline, in that picture of the pipeline, I exported this into documents as tickets. And you'll notice that what I've done is sort of broke out the column heading and associated next to the values. And this is just because of how language models tend to work. You can actually just essentially directly use a CSV loader or just there's even a database loader in some of the tools. In my own experience, that's a little bit of hit and miss, whether or not it does a good job associating the column heading to the actual values. So what I've learned to do, and what a lot of people do, is they'll just do a little bit of a translation when they export to make sure that there's a good binding between the column value and the column name and the value. It really improves the results that you can potentially get through your RAG pipeline. So that's just a little tip for you. Anyway, you'll see I've got like the same 5 tickets, and you'll notice again that what we've done is we've encrypted as early as possible. So even in that conversion stage, I've got the encrypted values here. Okay, and of course going to the actual the UI or the GenAI UI. I've currently logged in as guest. So imagine I'm the product manager, and I want to take advantage of the data in the customer support ticket to kind of understand how well a particular feature is doing. So what I'm going to do is I'm going to go ahead and ask a question about the new bill payment. I'll ask something like, did anyone file a ticket relating to problems with bill payment? And just to kind of show the ticket that might be relating to that, I think I had one here somewhere. Yeah, this one. So I have ticket 1004 related to bill payment. So I'll see if the system can actually find that, and maybe I can interact with it. Okay. And by the way, what we did, you may have saw earlier in my picture, we've added this specialized logging window that actually shows the traffic that's going to the LM or inference server. And the main goal here really is to show you that this is actually live and everything is actually going there. So what I'm going to do is ask the question, what is the ticket number? Again, just to verify this is all aligned here for the ticket with problems. Okay, so it matches, it's 1004. And again, you'll see that all the data is encrypted. This is the context that's being sent to LLM as part of the RAG process. Now, what I do want to do as a product manager is kind of understand what the problem is. So I'm going to ask it, give me the full description text for ticket 1004. Okay. Show me. The thing about GenAI is that it can be a little bit non-deterministic, so you kind of have to ask it the right question. Show me the details of ticket 1004. All right, well, I guess they do a good job of keeping the data from me. Let me just kind of demonstrate how, in fact, I'm not allowed to access any of that sensitive data value. So let me get, what is the email address associated with ticket 1004? Okay, so remember, my main goal as a product manager is to be able to use the GenAI tool to get information. But at this stage, the PII and sensitive data value that's under regulation, I'm not allowed to access. So the way that's designed is that since the data is encrypted, it will not decrypt for me. Just to make sure that the application doesn't break, though, Baffle is actually able to even do some basic masking to actually present it in a much more easier to consume form. So I can't access PII, but I can still use the GenAI application. But let's say that since someone is having bill payment issues, you may actually want to gain access to that email address and other information to follow up. You need someone who actually can solve the problem. So you go back to the same AI chatbot, and then you say, okay, which ticket had problems with bill payment? Again, ask the same question. It should give us the same results, 1004. Tell me the email address for the ticket, associated with ticket 1004. as you can see, the key difference here is that now that I'm a user who has a privilege to actually access the data value, I can't get that. And now I can, as maybe the support admin, go back and follow up with Jane Smith here and actually resolve the issue. So as I tried to explain earlier, it is critical to be able to give this level of access control so they can ensure least privilege for compliance. And as you can see with Baffle, you can actually do that even with generative AI. All right, so that's just the demo. And with that, I'm going to turn it back over to Sushan.
All right, thank you, Ben Hank. And then let's go back to the presentation. So doing a quick poll. So you saw the demo and we're curious, would you like to try data security for Gen AI? And you should see the poll question. It gives us a good way of telling you whether this kind of this demo actually piqued your interest. Just give people a second to respond. Okay, so let's move on. Let me try to close it up. We've got about 7 minutes to try to get some of your questions answered. So 3 things you should walk away from. First is data security and compliance. It's a big problem. RAG and other usage of sensitive data in Gen AI is going to have increased risks of data leakage, right? As Min-Hank showed, the best way to address this is by protective sensitive data at the field level, right? Each PII value, as early in data pipeline as possible. The kind of model of, oh, there's an object like a table I can guard, does not work that way with LLM. So you have to rethink how you approach data security and compliance. We provide an easy way to enable field level encryption and access control for Postgres. So that gives your Gen AI applications that use Postgres a safe way to use private data with sensitive data. So next steps, if you want to try this, if you have your phone available, just zoom in on that QR code. It will take you to a page where you can set up a meeting with one of our security experts. They're going to do 2 things. They're going to qualify your Gen AI data security needs and then give you a guided tour to the Gen AI demo sandbox, and then you'll have access to it. You can also, if you just type, if you don't have your phone available, info.baffle.io/demo/GenAI, pretty simple. Or if you think the bit.ly link is easier, you can do that. So let's get to your questions. There was a question that was asked, does the prompt augmentation step involve refining the user query like prompt engineering? Parth, can you respond to that?
Sure. So the prompt augmentation piece does not refine the user query itself. What it does is it augments relevant data from your data sources to the prompt, which in turn increases the accuracy of the response from the LLM.
Great. And there's another one. Does the similarity search work on encrypted data, or is the data decrypted during the search? Min-Hank? You're on mute right now, Min-Hank. There you go.
Yeah, I answered in the chat, but I'll go ahead and also explain here. Basically, the embeddings are generated on the encrypted data values. The key here is that we're encrypting just the compliance or regulated data value, which typically are personal identifiable information. These are things that aren't that meaningful if you think about it in the context of a language. How Gen AI generally works is that it's taking advantage of the relationships between the words as it's used. That's why they're language specific. You wouldn't try to use an English model for French, for example, right? Everything is generated very specifically. So if you have that level of understanding and you realize, okay, well, all this generation, all this understanding of the language is tied to meaningful words and the relationships. Email addresses, credit card numbers, even arguably street addresses don't really have very close binding relationships to all the other normal words, your typical nouns, verbs, and adjectives and whatnot. So what we found even in our own experiments and our own tests is that if you encrypt PII, and most of these sensitive data, pretty much all of these sensitive values are going to encrypt, it'll perform generally just fine as before. And you get the advantage of being able to control the access to PII without actually degrading the quality of results that you get.
Great. Here's a question for you, Minhank. Does Baffle only support Postgres as a vector database?
Yeah, I kind of alluded to that earlier, but it's good that we kind of good that someone asked about this. No, I mean, Postgres obviously is very powerful and it's incredible. It's something that our customers ask for, but we actually are agnostic to the database, right? Because what we do is we encrypt the data so early in the pipeline that no matter where you send your embedding and your document chunks, it's going to remain protected. So you're in good hands whether you use Pinecone or you decide to just use some of the other native. I think all the infrastructure, AWS even offers some alternatives where we can store embeddings straight onto unstructured storage as well. Yeah, it's fine.
Great. Parth, I think this question's for you. How would you increase accuracy of search results when querying your knowledge base with Bedrock?
So knowledge bases have this feature called metadata filtering. So what you can do is add key value pairs to the data that you're storing as vector embeddings within the knowledge base itself. And these can be used to perform efficient and accurate searches. So once you add these tags and key value pairs, it makes it easier and more accurate to retrieve results that's part of the question that you ask the knowledge base.
Awesome. Now we're almost out of time. Maybe one or two more questions. Minhank, here's one. My company uses data loss prevention. Why can't I use that with GenAI?
Well, actually, you can use it with GenAI. It's probably not going to be as effective as you would like it. I mean, at the end of the day, what data loss prevention is trying to do is sort of have this checkpoint, typically between your internal network and external network, or some boundary. It's kind of scanning for some obvious, I guess, patterns, right? The thing about GenAI, or just even before GenAI, honestly, it was well recognized that DLPs are hardly foolproof. There are many ways that you could actually bypass it, or it just has lots of false negatives and even false positives. With GenAI, the way that the data is returned has now given to the control of the user, right? So, for example, with DLP, you would have system-to-system communication, and those formats are well understood. With GenAI, if I wanted to bypass DLP, I could actually tell the engine to respond to me in Klingon, for example. I'm pretty sure there are no DLP rules that are written in Klingon, right? Or just have some trick. And you heard this with prompting attacks before, where you can get the system to actually kind of help you in trying to bypass itself. And that's the scary thing about GenAI. And that's why we focus on this data-centric protection, right? What you need to do is, independent of what the GenAI is going to do, start with a fail-safe posture for that sensitive data value that's regulated.
All right. And so with that, we're pretty much out of time. So let me turn it over to Hormas to wrap it up.
Okay, well, thank you everybody for joining us. We really appreciate you interacting with us as well. And thank you to our speakers for sharing this great content. As a reminder, everybody, you will be getting a link to the recording in your email, so keep an eye out for that. And please feel free to share the webinar with your friends and colleagues. Hope to see you on our next webinar and hope everybody has a great day. Thanks and bye-bye.